What's up, y'all? Alright, last time we talked about what parts of triangles are congruent. What parts of congruent triangles are congruent. Like, their corresponding angles are congruent, and their corresponding sides are congruent, and all that's awesome to show that those triangles are congruent. But sometimes we don't want to go through showing all of those things, like all 6 of those things, like all 3 pairs of angles and all 3 pairs of sides. That's a whole bunch. So there are some shortcuts to use to prove that triangles are congruent. One of them, first one being side-side-side congruence postulate, says that if all 3 pairs of sides of 2 triangles are congruent, then those 2 triangles are congruent. So let's write that out. If all 3 pairs of sides of 2 triangles are congruent, then those 2 triangles are congruent. So if you know all 3 pairs of sides are congruent, then those 2 triangles are congruent. And you can write a congruence statement, like triangle MPN is congruent to, well, who was M congruent to? Q. And P was congruent to S, and N was congruent to R. Sweet. That's the side-side-side congruence postulate. The side-angle side, you guessed it, is going to use a side and an angle and a side alone to prove the 2 triangles are congruent. But which angle you use is very important. The angle that you use must be between the 2 sides that you're using. So we've got RQ, which is congruent to VT. They both have the same measure. And QP is congruent to TS. Those have the same measure, and the angle between those 2 sides, angle Q, is congruent to the angle between those 2 sides, angle T. So let's write that out. If 2 pairs of sides and the angles between them, those sides of the 2 triangles, are congruent, then the 2 triangles are congruent. Hot dog. Right, so again, the 2 sides that we're using make that angle that's congruent. So I couldn't use it if the angle was angle P, right? Because angle P is not made up of the 2 congruent sides. So let's write our congruent statement for these triangles. We got triangle RQP congruent to, who does R match up with? Well, V, and Q goes with T, and P goes with S. Boom shakalaka. That's 2 of them, side, 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 and side, angle, side. Now we have angle, side, angle. Really similar to side, angle, side, but like backwards. So we've got angles that are congruent, and the angle and the side between those 2 angles congruent. Right? So if 2 pairs of angles this time, and the side between those angles, if those are, of the 2 triangles, if those are congruent, then what's going to happen? Well, the triangles are congruent. The 2 triangles are congruent. So let's write our congruent statement. We got triangle DFE congruent to, well, who's D congruent to? A. Who is F congruent to? C. And E is congruent to B. Okay, and last but not least, angle-side congruence theorem. The angle-angle-side congruence theorem says if two angles in a row, right, one right after the other, congruent, and a side are congruent. So if two angles and the side that's not included with those two angles, so it's different from the last one because the side here was between the two angles, the side here is not between those two angles. So if two pairs of angles and one pair of sides of two triangles are congruent, then the two triangles are congruent. So again, let's look at the difference between these two congruence postulates. In angle, side, angle, we have an angle, a side, and an angle, and the side is between those two angles. In angle, angle, side, the side is not between those two angles. Angle, angle, side. Okay. So our congruent statement here is going to be triangle A, B, C congruent to triangle. Who is A congruent to? A was 75. Y is 75. B is the one that's not labeled, so that's going to be X over here. And C is 65. Z is 65. That's what we got. All right. Side, side, side. All three pairs of sides are congruent. Side, angle, side. Side, angle, side. The angle between two sides is congruent. Angle, side, angle. The side between two angles is congruent. And angle, angle, side. The side is not between those two angles. If you have any of these situations, you know that the triangles are congruent. So, let's do some examples. Why is triangle KLM congruent to triangle NMP? Well, gosh, let's look at these markings on this triangle. This says KL is congruent to NM. I'm going to write down some evidence right now. KL is congruent to NM. This says LM is congruent to MP. MP. And this says KM is congruent to NP. So that looks like three pairs of sides that are congruent. Calling this one side, side, side for the win. Yes. Gonna give you a minute to try this one. Is it possible to show that the triangles are congruent? If so, state the postulate or theorem. Well, okay, so I was gonna give you a minute, but now I'm walking through it. We know X and Y are both right angles, and all right angles are congruent, so we know that triangle X is congruent to angle Y. We know these sides are congruent because they have the same number of hash marks, so we know side XW is congruent to side YW. That's two things. We need three things. What else can we see in this diagram? Vertical angles. Oh yeah, we got some vertical angles that are congruent. Hey. So because W could be a part of a lot of different angles, let's be real specific here. This is angle BWX. Angle BWX is congruent to angle ZWY. Angle ZWY. So we've got an angle and a side and an angle, and that side is between the two angles. Angle, side, angle, ladies and gentlemen. Nicely done. All right. We're doing wonderful. Oh my God, oh my God, oh my God, oh my God. Proofs. Freak out. Relax. Can do this. For sure can do this. Okay. Triangle proofs. All of our final answers here are going to be either side, 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 angle, side, or angle, angle, side. Those are the 4 ways to prove triangles are congruent. So let's look, see what we got. Alright, it says VW is congruent to YW. Well, I mean, that's given. And then this says vertical angles is going to be our reason for number 2. Well, where are some vertical angles? They're right across from each other, these guys. So angle VWZ is congruent to angle YWX. Cool. It says given again. What else is true from the diagram that we didn't mark up? Well, we talked about VW being congruent to YW, but ZW is also congruent to XW. Ooh, ZW is congruent to XW. Très bien. So now we've got a side and an angle and a side, a pair of sides, a pair of angles, a pair of sides in that order that are congruent. So that means the triangle BWZ is congruent to triangle YWX by side, angle, side. Oh yes. Oh yes. Wonderful. Alright, let's move on to number 2. Well, number 2 doesn't even tell us anything in the statements and reasons, but the diagram does, so that's cool. Let's look and see what we got. We got side BC is congruent to side DE because they both have 1 hash mark, so let's write that down. Side BC is congruent to side DE. That's given in our picture. AC is congruent to FE because those both have 1 hash mark. Also given. And AB congruent to FD because those both have 3 hash marks. Given. I think that we have 3 pairs of 3 sides congruent. So that's going to be side, 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 side. Triangle A, B, C congruent to triangle F, D, E. We're like so good at this. This is so good. All right. Number 3. Prove the triangle TQS is congruent to triangle SRSQ. Well, fortunately, the diagram showed up right in the middle of our notes. Cool, so let's redraw this picture. That is angle R, and that is angle T. So we're going to redraw this picture so it's not a complete mess. That's angle R, and angle R has 2 marks, and this is angle S, and it has, for this triangle here, 1 mark, and that's Q. And then we've got another triangle. That's angle T. That has 2 marks. Angle S for this triangle here has no marks. And there's a Q. Alright. So, the things that we are given. Yeah, I think I'm going to write it on the top. It's going to be fine. Angle R is congruent to angle T. That's given. That says R is congruent to T. Just kidding. I'm going to write it down here because that's a mess. Statements, reasons. 1, angle R is congruent to angle T. That's given. Number 2, we got angle... Oh, who did I forget? Oh, in this triangle here, Q needs 1 mark. So angle S is congruent to angle Q because they both have 1 hash mark. There's also one more thing that's congruent. See how this says QS? And that says QS? Well, QS is definitely for sure congruent to itself. What's that called? What's this congruent to itself? The reflexive property! Nicely done! Reflexive property of congruence. Something's congruent to itself. So we have an angle and a side that is congruent, but that side is not between So that's angle, angle, side. Whoops, that's our reason. Angle, angle, side. And the triangles are SQ congruent to